Hi everyone, it's Miss Peters. Today I'm going to go over the classification of matter notes with you. If you are, or if you weren't in the Zoom and as you watch this video, you're going to have to hit pause because I'm not going to give you enough time in the video to write it down. Otherwise it'd be slightly awkward, me just staring at the screen. So just hit pause and keep playing once you have things written down. So, classification of matter. First, what is matter? Matter is anything that is composed of atoms. So everything is matter. The air in the room, our tables, everything is composed of atoms. Things, just because it's not living, still made of atoms. And so matter can be broken down into two categories. You can say something is a pure substance or it's a mixture, and it just depends on what is in that sample that you're talking about. And so what's the difference? A pure substance is when all of the particles in a sample are identical. It's all one thing you're talking about. And pure substances can be elements or they can be compounds. A mixture is when you have different types of particles in the sample. So maybe you have different elements. You have carbon and hydrogen in a sample, or you have elements and compounds. Maybe you have, like the air we breathe is oxygen, it's an element, nitrogen, carbon dioxide, who knows what else is in this air that we breathe. That would be considered a mixture because there's different stuff, or a mix of different compounds. And then mixtures can be classified as homogeneous or heterogeneous. And so what is an element? An element is something that cannot be separated by a chemical change or physical change, and it consists of one type of atom. All elements are represented by a symbol on the periodic table: gold, hydrogen, potassium. So if you're looking at something like, is that an element? You can find the name on the periodic table, it is. Carbon dioxide, you can find carbon on the periodic table, but you can't find the word carbon dioxide on the periodic table. So that is not an element. And then that's a big thing with one type of atom is an element. And so if we were to look at a particle diagram, it's just like a diagram showing the atomic level, what they look like. We would see that in an element, it's all the same shape, all the same thing in a sample. So this picture on the right, they're all just circles in there, individual circles. That would be considered an element. The box on the right could be an example of oxygen. And so there are two squares together, but do you see how they're the same shape? That means it's the same type of atom, because when you make a key, we would say the square is O. And so that's just O and O. And that definition of element is one type of atom. Okay. Versus a compound is made of different types of atoms that are chemically bonded. I'll highlight that together. Compounds can be separated by chemical changes, but not by physical changes, and they're represented by a formula. And so when you look at the formula for a compound, you'll find that there are different atoms and there are different types. Like water is hydrogen and oxygen, two capital letters. Carbon dioxide, carbon and oxygen. Sodium chloride, Na, sodium, chlorine, Cl. And there's not an and sign between them because they are chemically bonded together. And so we can separate compounds, but it would require a chemical change. One example is electrolysis, is a way to break apart water molecules. And you can actually separate water into hydrogen gas and into oxygen gas. But that requires a chemical change. You're actually separating them. And then remember the difference, elements cannot be separated. And how a compound would look in a particle diagram, there would be different shapes. And so we might say for this one that the square is carbon and that the circle is oxygen. Actually, that'd be backwards for carbon dioxide, but it's all the same thing in the sample. They're all the same shape in there. They're all two squares in a circle. That's what makes it a pure substance, that it's all the same thing in there. Okay, mixtures. Mixtures are two or more substances together in a sample, and they can be separated by physical changes. Salt water is an example of a mixture. And when you look at the formula for salt water, you'll see that it says NaCl plus water because the salt is not bonded to the water. They're separate things, and that's why they can be separated by a physical change. All mixtures, if you looked at an equation for them, have a plus sign or an and sign in there because there are two different substances. And we have two types of mixtures: homogeneous mixtures, which is where you have two or more pure substances mixed evenly. And when you look at it, you can't tell that, you might know that there's different stuff in there, but you can't see it. And homogeneous mixtures are often called solutions. So some examples: when I look at that bowl of ice cream, in my head I know there's milk, there's sugar, there's, I don't know what else is in ice cream, but I know there's different stuff in there and that they're not actually bonded together, they're mixed together. But looking at it, I can't see the sugar and I can't see the milk, I just see ice cream. So that's a homogeneous mixture. Same with the picture of the Coke. I know soda has water, I know there's food dye, I know there's sugar in there, and who knows what else is in soda, but looking at it, it all looks the same. And if you remember biology, homogeneous mixture looks the same. Homozygous alleles, they were the same. They were both small or both recessive or both big, both dominant. So homogeneous mixtures look the same. Homozygous alleles, they were the same. It's a way to remember that. Heterogeneous mixtures, when you look at it, you can tell there's different stuff in there. They're mixed unevenly. So some examples: fruit salad is a heterogeneous mixture. When I look at it, I can see strawberries, oranges, raspberries, etc. Pizza, granite's a rock. Looking at that rock, I can tell there are different parts to the rock. That's why it's a heterogeneous mixture. And if we were to look at a particle diagram of a mixture, you can't tell from a particle diagram if it's homogeneous or heterogeneous, but you can tell it's a mixture because there's different stuff in there. Like here's one type of compound, but then here's another type of compound, and then here's an element, and here's another element. So it's not all the same thing in the diagram, versus an element would just have one shape in the box, and a compound would have two shapes, but it'd be all the same type of molecule in there. Mixtures have different stuff. And there are ways to separate mixtures, because if we remember, mixtures can be separated, but by physical means. And so some ways you can separate mixtures: with magnets. If one of the substances is magnetic, easy way, put a magnet to it, it'll separate the two things. Sieving, you probably did sieving like in elementary school, where you shake it in the sand and you can separate the different parts out. Evaporation, if you have salt water, you can boil the water out, the salt would be left. Filtration, think like a Brita filter. If you have that in your refrigerator, separates out the nasty stuff from the water. Or you could use like a funnel and filter paper. Decanting, if you've got, I think that's sand and water, pour the liquid out, the solid should be at the bottom. Distillation is a way to separate two liquids or a solution. And remember, a solution's a homogeneous mixture. So in this picture, we've got a solution of water and ethanol. Well, ethanol boils at 78 degrees. So you get this solution to 78 degrees Celsius, and the ethanol will boil out. And then what's left is just water. And so that's another physical way to separate mixtures. And so we're going to take a second, and I want you to try and classify these diagrams as either an element, a compound, or a mixture. And then pause the video, do that, and here are the answers. So number 1 would be an element. Remember, element, one type of atom. It's all the same shape. 2 would be a mixture. There are 2 different compounds in there. 3 would be a compound. 4 would be a compound. 5 would be an element. And 6 would be a mixture, because that's a compound and an element. And so that's it for our notes